Hi students, welcome to the session on significance of impulse response. Uh, in this video, we see why should we need impulse response, how it is related to frequency response and translation. I will explain with one example that will make you to understand the importance of learning these parameters. Right? First, let us take one system which is defined by the equation y of n is equal to x of n plus x of n minus 1, right? So I want to find impulse response. How can we find impulse response? First I take z transform, so it will be y of z, this is x of z plus z inverse of x of z, right? So now what I do, I find y of z divided by x of z, that is what, h of z, right? Z transform of output divided by z transform of input, that is equal to transfer function. This is 1 plus z inverse. So I got z h of z. From that I can find h of n, take inverse z transform. This will be equal to h of n, that is given by 1 comma 1. Right? We know how to find the inverse z transform of 1 plus z inverse. Right? So this is what our h of n. Now we got impulse response and the transfer function. Okay? Now we see the beauty of impulse response. H of n is 1 comma 1 and the transfer function is 1 plus z inverse. We know that if you want to design any system, you have to design an impulse response, right? Let me assume I have an input signal x of n which is having a value of 1, 2, 3, and I assume that this is my impulse response h of n. H of n is 1, 1. What is our output? My output is y of n is equal to x of n star h of n, convolution between these two values. So we know how to get the convolution. If you take the convolution, here I take h, here I take x, here I take h. So x is 1, 2, 3, h 1, 1. So find the convolution 1, 2, 3, 1, 2, 3. What I get is 1, 3, 5, 3. So y of n is equal to 1, 3, 5, 3. Right? So now we come to one conclusion. Let us see if x of n is 1, 2, 3, right? So I give 1, 2, 3 as input. This is our x of n that you give as an input to a system with impulse response 1 comma 1. What we get is that's what y of n, that is 1, 3, 5, 3. This is x of n, this is h of n, this is y of n, right? See, what is y of n? Y of n is first one, these two are added, then these two are added, then this is added with the next one. That's what our output. What is the thing I have done here? Y of n is x of n plus x of n minus 1. Why? You see, I want to find, this is n0, n1, n2, n3. Y of 0. Y of 0 is x of 0 plus x of minus 1. X of 0 is 1. X of minus 1 is 0. That's what 1. Y of 1 is x of 1 plus x of 0. X of 1 is 2. X of 0 is 1, 3. Y of 2 is x of 2 plus x of 1. X of 2 is 3. X of this fellow 1 is 2. So 2 plus 3, 5. Similarly, y of 3, x of 3 plus x of 2. Yes or no? X of 3 is, what is x of 3? X of 0, 1, 2, 3. X of 3 is x of 2 x of 3 is 3, x of 2 is 5. Okay, you see, not it is this y of n. X of 3 is 0. This is x0 1 2. X of 3 is 0. X of 2 is 3. So what is the thing? We have added present sample and past sample. Present, y of 0 is present, x minus 1, x of 0 is present, x minus 1 is past. Y of 1, x of 1 is present input, x of 0 past. Y of 2, present output, present input, past input. Present output, present input, past input. That's what I have taken here. You see, what is the question I have given? I want my output should be like this. What I did? I designed only impulse response with h of n 1, 1. So if my h of n is like this, if you give any x of n, the output will be like this. Yes or no? That's what we are understanding from this, right? So this is the, now you understand why we have to design only impulse response. So for y of n is equal to x of n and x of n minus 1. If I want output like this, what should be my impulse response? My impulse response should be 1, 1. My transfer function is 1 plus z inverse. So what is the nature of the system? This is nothing but I give my okay, I make it y of z divided by x of z is equal to 1 plus z inverse. This implies y of z is equal to 1 plus z inverse into x of z. This is x of z, right? Here you add, this is z inverse. This is the hardware structure y of z. Here 1, here z inverse, here 1 plus z inverse. Right? So 1 plus z inverse into x of z. Okay, so this is x of z, right? So this is the way we can get the answer. Right? This is the hardware structure. Next we see another one beautiful things. H of z is given by 1 plus z inverse. I want to find what is the nature of the frequency response. If you want to find the frequency response, replace z is equal to e power j omega. That is, find dtft. Z is equal to e power j omega. So it is 1 plus e power minus j omega. Right? It will be, I take e power minus j omega by 2 outside. So it will be e power j omega by 2. It is minus e power j omega by 2. Right? This is e power minus j omega by 2. It is 2 cos omega by 2. Right? So this is what my frequency response. What is the magnitude response? Take the magnitude. Fine. So it will give mod e power, take mod less, mod e power j is 1. So what we get is 2 cos omega by 2. Right? So you take x-axis omega, y-axis h of e power j omega. What is the nature of the signal? When omega 0, maximum cos 0 is 1, so the magnitude is 2. So it is a cos wave, it's purely cos wave. When omega varies, when omega is equal to pi, it is cos pi by 2. Cos pi by 2 is 0. So it is like this. It will go like this. You see, it is some crude low pass filter response. Clear or not? Ideal low pass filter will be like this. It is some crude low pass filter, right? So this is the way my systems will work. We know low pass filter is averaging filter, right? So in that problem, if you make y of n is equal to x of n plus x of n minus 1 by 2, what will happen? That 2 will divide this, so it will become 1. So it is equivalent to perfect low pass filter, normalized low pass filter. That 2 works as a normalization factor, normalized low pass filter, right? So this is the way our impulse response, transfer function, and frequency response are related, right? This is the way a system is designed in real life. Okay, so I hope you understand this concept clearly, right? What we have to do whenever you want to design a system, we know what is the nature of what is the output I want. This is what I want. This is what I have. So if I want from this to this, what is the only thing I have to do? I design h of n. So h of z is useful for system design, right? It is for to get whatever we want, h of, right? Whereas h of e power j omega, that is frequency response, it indicates how system responds to different frequency, right? So this is frequency response, this is impulse response, this is transfer function, right? I hope understand this. If you have any doubt, please ask me in comment section. Thank you.